So just to answer one question, Jerry, for this question 8.3.2, you said what question? So, have you ever watched or did you know this game show Who Wants to Be a Millionaire?
No.
Never? Okay. Albert or Emma, do you guys know Who Wants to Be a Millionaire? This kind of show exists in many countries. So basically, they give you a lot of usually like 10 to 12 difficult questions, and you're gonna just you try to answer them. In this case, you have 15 questions, and if you can get all of the questions correct, then you can win $1 million. Then you become a millionaire.
But if you
Okay,
get one wrong, you basically don't get anything, I'm assuming.
yes. So basically, you can choose to progress or not. So for example, if you get the first question right, you can choose to stop and then get $100 back.
It's
Back.
really, really stressful again.
Yeah, it is. So that's why this kind of show in many countries they receive a lot of audience. A lot of people like to watch them. Yeah. So say that you get 7 questions right. Usually the first few questions are very easy. Everyone could get them right. But starting from like 8, 9, 10, it can be really difficult and it can be more and more difficult. And all the questions are just trivia related. So they will ask you very uncommon facts, so a lot of people don't know. Yeah, that kind of stuff. Yeah, so at any question you can choose to stop and get the money back, or you can choose to proceed. But if you proceed and you get the next question wrong, then you will lose everything. Okay, yeah. So the question here is asking between which two consecutive questions is the percent increase the smallest? So for example, from question 1 to question 2, right? You go from 100 to 200. That's double in value, right? And that means you have 100% increase. And then 200 to 300, that's only 100 increase. 100 divided by 200, that's 50% increase, etc., right? You can see a lot of doubling here. So this is doubling 500 to 1,000, 1,000 to 2,000, 2,000 to 4. All of these are like doubling. So doubling means that you have 100% increase, right? So these are doubling too. So, he's asking for the smallest. So maybe here, maybe here, maybe here. Maybe here. Because all the other increases are doubling. So all the other increases are just 100%. So the smallest might be just from 2 or 3 or maybe 3 to 4. That's for you to figure out. Does that make sense to you now? Is the meaning of this question? Yeah. Okay. So it shouldn't be too hard. Yeah, that's just to clarify some meaning of the question, and then let's continue our chapter 7 questions. Today, let's see. We still have 1, 2, 3, 4, 5 more questions to go. Yeah, we will see. Maybe you can finish 3 or 4. Okay, so start from 762. This question, none of you guys got it. So I want to see why, because I don't believe this is a hard question. It doesn't really even have a star on it. So I think the most difficult part probably stems from the meaning of the question. Maybe the meaning of the question can be confusing, the wording. So 1 minute, have a minute for you guys to read the question again, and then let's see which part of the question confuses you in terms of meaning. Oh, okay. 没关系，不影响，没关系。Okay, has everyone finished reading it? So what is talking about? they are mirror making, right? They're making mirrors. And the largest mirror, so this word, what does this word mean? Radii, anyone? It's just a plural form of the word radius. So here, radius, I think you guys know what it means, right? Yeah, so radii is just a plural form of radius. Okay, so if we draw a circle, there's a circle center, right? So from the center of the circle to any point on the circle, from the center to anywhere on the circle, we say this is the radius r. Okay, the word radius, when you get a plural form, then that becomes, it's not radiuses, it's gonna become radii. Okay, we read it radii. So just for your information, any word that ends with us is a Latin word, okay? And any word ends with us when they get when they become plural, when they become like two or more, you change the us part into I. Okay, so similar words, for example, we have a stimulus. There's no what stimulus is. Something that stimulates you, right? Stimulus. And if you have like two stimulus, three stimulus, we don't say stimuluses, we say stimuli. Stimuli, okay? You change the US part into I. That's a Latin suffix, okay? Something like fungus. Fungus just means mushrooms. It's like a biological name of mushrooms. And again, when you have more than one, it's a fungi or fungi, okay? So US and words ended with US, yeah, you change into I when you need to use the plural form. Does that make sense? Okay. Yeah, just some common sense yeah, about the language part. So radii here just means radius, okay? So their largest mirrors have radii of 5 meters, okay? And the smallest mirrors have radii of 1 meter. The smallest, yeah, just 5 to 1, right? And what it says about the cost is that the cost of every mirror is proportional to the cube of the mirror's radius. What does this mean? The cube of the mirror's radius. So we know that the largest mirror to the smallest mirror, the radius is 5 to 1, right? So let's say maybe draw. Let me first draw two kind of mirrors, right? Here's 5, here's 1. So let's say the largest mirror, the largest radius, let's use the capital R. Okay, this is the largest radius. And use a small r to indicate the smallest radius, okay? So we know that the largest radius to the smallest radius, the ratio between them is 5 to 1, right? The question is asking about the total cost. So let's first figure out the cost of making a large mirror, of making the largest mirror, and the cost of making the smallest mirror. Okay, the cost of the largest mirror and to the cost of the smallest mirror, how do we figure this ratio out? Anyone? What is the ratio between the cost of the largest mirror and the smallest mirror? The radii, the ratio of the radii is 5 to 1. And their cost is proportional to the cube of the radius. Anyone has any idea? What does that mean? The cube of the radius? Any guess? Albert, Jerry? No? Nothing? Oh, okay. So, okay. So,
75.
what?
75.
75. Well, why do you believe it's 75? Like, how did you get 75?
Oh, because I multiply by 25 at the end.
Yeah, you multiply by 25. That's correct. That's correct. But 5 times 25, is it 75?
I don't think so.
Yeah. 25 times 5, you see? 5 times 5, 2
Oh,
times
1, 2,
2,
5. Yeah,
1, 2, 5, right?
Mm.
Exactly. That's 1, 2, 5 to 1. Okay, very good. Yes, Albert got it. That's 1, 2, 5 to 1. The cost of making the largest mirror to the smallest mirror is 1, 2, 5 to 1. Why? Because it says the cost is proportional. Proportional means that if if something get bigger, you get bigger. If something gets smaller, you get smaller. That's proportional, right? The cost of making mirrors is proportional to the radius. That should make sense because the larger the radius is, the larger the mirror is, right? And then if you want to make a bigger mirror, of course you're gonna spend more money. It's gonna take more cost, right? It's gonna cost you more. Okay, the larger the mirror, the higher the cost, right? And how high? It says to the cube of the mirror's radius. Now, we know 5 to 1 is the ratio of mirror's radius, right? But the cube of it will be the ratio between their cost. That's basically what this sentence is saying, right? Does that make sense, Jerry and Emma? See that make sense? It's basically just saying that the cost of making these mirrors is like the ratio of making these mirrors is just the cube of their radiuses. Sorry, the cube of the radii. The cube of the ratio of the radii. And the ratio of the radii is 5 to 1. So basically, you're going to cube the 5 to 1. So basically, it means that you're going to do 5 cubed and then 1 cubed. Okay? So it's going to be 5 cubed and then 1 cubed, which equals this. Okay? To further understand this, recall that ratio are just fractions, right? Ratios are just fractions. So 5 to 1, you can see it as 5 over 1 and then cube. So that's why you can just cube here and cube here, because recall that in a fraction, if you need to raise a fraction to a power, you just raise the numerator and the denominator to that power. Okay, is there any question about this part? So 5 to 1 is the ratio between the radii. You can change that into a fraction and then you cube it, right? Because the question says you're going to cube it, right? After you cube it, you get the ratio of the costs. Okay, the ratio between the costs of making the largest and smallest mirrors. So I think that like the part of this, like the part of this question that might thwart you from solving it might be this sentence. Like maybe the meaning of this part is not totally clear to you guys. Okay, you guys think this makes sense? Then we can continue. So the cost of making one largest mirror to the cost of making one smallest mirror is 125 to 1, right? But the question is not just asking for this. The question is asking for what is the ratio? Actually, it's asking for the ratio of the total cost of 25 of the smallest mirrors to the cost of one largest mirror. So it's actually asking the cost of one largest mirror to the cost of 25 smallest mirrors. Then what do we do here? One largest to one smallest is 125 to 1. So for example, to make a smallest mirror, maybe you spend $1 on it. To make a largest mirror, you're going to spend $125 on it, right? And the question is asking, what is the ratio between the cost of making one largest mirror and the cost of making 25 smallest mirror? Not just one, but 25. What do we do?
125 to 25.
Yes, 125 to 25, right? So Jeremy, I'm gonna see if that makes sense. The cost, the ratio between the cost of one largest mirror and one smallest mirror is 125 to 1. So if you want to make 25 of the smallest, you're going to multiply this one by 25, right? Because you're going to make 25 of them. So that becomes 125 to 25. Okay, another way to understand this is that you can just assign some values. Let's say we spend $1 to make a smallest mirror, and then we need $125 to make the largest mirror, right? This should make sense. The cost is this, right? The ratio of the cost is this, and then it's just a cube of their radii, right? The cube of their radii. And then to make one largest mirror, you're gonna have $125. To make one smallest mirror, you're gonna use $1, and you're gonna make 25 of them. So that means you're gonna spend $25 to make 25 smallest mirrors. So the cost becomes 125 to 25. Okay, so go here, you're gonna multiply 25. Can that make sense? And finally, just gonna cancel out, right? 125 to 25, divided by 25. So this becomes 1, this becomes 5. So in the end, we still get 5 to 1 as our answer. Okay, does that make sense? Jerry and Emma? To use some like better and more accurate math notations, then we can do this. So we can suppose, R and R to be the largest radius and smallest radius. So let's write down radius. And then we use like C, maybe capital C and a smaller c to represent the cost of making them, right? So let's say C and smaller c represent costs of making bigger and smaller mirrors. Okay, so now we can say that the ratio between their cost is the cube of the ratio between their radii, right? That's just that's what the second sentence is saying. Remember, the cost of making mirrors is proportional to the cube of the mirror's radius. So that's the equation you can get, right? Cost of bigger mirrors, cost of smaller mirrors. And we know that the ratio between the radii is 5 to 1. So that's how we get 125 to 1. Okay, so 125 to 1 is the ratio between their costs. But the question is asking, what is the ratio between the cost of making one bigger mirror but 25 smaller mirrors? So obviously, if big C over smaller c is this, then big C over 25 smaller c, you just do 125 over 1, and on the 1, you're going to multiply by 25. So in the end, you get 5 to 1. So 5 to 1 is the answer. Okay, Jerry, Emma, any more question about this before we move on? Okay. To Emma? Any question? No? No? Okay, good. Okay, next. So 763. This one, Emma got it right. Jerry and Albert didn't get it. Didn't get them. So let's have a look at it. Okay, read the question again, and have a minute. Okay, I believe the meaning of this question should be straightforward. Basically saying that the ratio of the votes between Kim and Amy is 3-2, right? 3-2. Kim received 3 votes for every 2 that Amy got. It means that the ratio between their votes is 3-2. However, if 8 of the people who voted for Kim had voted to Amy instead, so basically, if the number of people who voted for Kim, -8, because 8 of people basically turn coat, right? If they turn the coat, so 8 less people voted for Kim and 8 more people voted for Amy, then the ratio becomes 1-2. Okay, that's what it means. And yeah, we're gonna figure out how many people voted. So does anyone have any idea? Just want to make sure that we haven't talked about similar questions before. Okay, so for this this kind of question requires not a special way, but just you could say a general way to solve it. Okay, so I'm gonna go over this general way, and hopefully, and this method is something you must master. Okay, because in many school problems and also competition problems gonna have something like this, and once I cover it, you will know what I meant. Okay, so if any question tells you a ratio about anything, okay, a ratio of anything, you can always suppose them to be some x's. Okay, so first we know that the number of votes that Kim received and Amy received is 3-2. This part, right? So we could say that votes for Kim to votes for Amy is 3-2. Whenever you have this kind of condition, and then in the end, you need to figure out how many people, how many votes there are, you can always suppose x's. And how do we suppose x's? Since the ratio is 3-2, the best way to suppose x's is to do 3x to 2x. See if that makes sense to you. If you suppose the number of votes for Kim to be 3x, and you suppose the number of votes for Amy to be 2x, then the ratio is automatically 3-2, right? Because x can be canceled. In other words, if x equals 1, think about this. If x equals 1, then the votes are actually just 3-2, right? So it satisfies the ratio. If x is 2, then you have 6-4. 6 people, right, voted for Kim, and 4 people voted for Amy, which makes the ratio 3-2 again. If x is 3, you get 9-6, and etc., right? Say x equals to 10, you've got 30 people voted for Kim, 20 people voted for Amy. Right? So 3x to 2x is the best way to suppose the variables here. Because if you do this way, you just need to deal with integers. Does that make sense? Okay, in the future, whenever you have this kind of questions and you need to figure out the numbers of each part, right? Okay, you have some ratios, and the question asks you to figure out the exact numbers of each part. Then you have to suppose some x's and try to make an equation. Okay, now if instead you didn't do this, then you have to deal with fractions. So for example, if you had suppose say the number of votes for Kim to be x, then that's going to be really difficult, because if you suppose that to be x, then how many people voted for Amy? Then you have to do a little equation, right? You can say x is the votes for Kim, question mark is the votes for Amy, and that's going to be 3/2. And to figure out this question mark, That's going to be basically you're gonna solve for the question mark. So that's cross multiplication, right? 3 times the question mark is 2x and divided by 3. So the question mark is 2x over 3. You see, if you suppose the number of people who voted for Kim to be x rather than 3x, just a single x, then the votes for Amy has to be a fraction because this is 3 to 2, right? So that has to be a fraction. And that means it's gonna make you make the whole thing difficult because to deal with fractions it's gonna be harder than dealing with integers, right? But in other words, if you look at this ratio and this ratio, they're exactly the same ratio. If you just time the first ratio by 3, right? If you time it by 3, time it by 3, 3 cancel out, you just get 3x over to 2x. Okay, does that make sense? So supposing one quantity to be x is going to be very, very difficult because if it's supposed to be x, based on the ratio, you have to first figure out what is the number for the other quantity. Or sometimes you have more ratio, right? You have multi-way ratio, right? Maybe you have 3-way, 4-way. Then you're going to spend a lot of time doing these, and maybe you make a mistake and then everything is wrong, right? So don't do this. This is not good, okay? No good at all. And even if you get very advanced in math, you still want to do this. Whenever you see ratio, you suppose this. It's very straightforward, right? 3 to 2, of course you do 3x to 2x. And the x can be canceled. And x can be any number, and you see that all of them make sense, right? Okay? Does that make sense? Any question about the supposing part here? Suppose the number of votes to be 3x and 2x, okay? We will see another example later on. So after this, we will do some more examples. So 3x to 2x. Okay, now this part of the question says, if 8 of people who voted for Kim turned into voting for Amy. So what that means is that 8 people from 3x is gone, right? They don't vote for Kim anymore, and instead they vote for Amy. So 8 people out of this 3x go to Amy. And if that happens, the ratio becomes 1 to 2, right? Kim received 1 vote for every 2 Amy would have got. So we can make an equation here. Does anyone have any idea what the equation is going to be? So 8 of the people who voted for Kim are gone. They are not voting for Kim anymore. So my question is, how many people are voting for Kim now? Originally, there were 3x people, right? Kim received 3x votes. That's what we suppose the number to be. 3x votes for Kim. Now, if 8 of those 3x people, they don't vote for Kim anymore. So how many votes does Kim have now?
3x minus 8.
Exactly, right? 3x minus 8. So, Jerry and Emma, that makes sense? 8 people who voted for Kim, they turn to vote for Amy, right? So that means now Kim only has 3x minus 8, this many votes. Does that make sense? Jerry, Emma? You do 3x minus 8. You suppose 3x first, and you minus 8, because 8 of people are gone. Okay, so Jerry, does that make sense? Yeah? Okay, good. Now what about the number of votes for Amy? Originally, Amy only had 2x votes, right? But now 8 of the people who voted for Kim turned to vote for Amy. So how many votes does Amy have now? Anyone?
2x plus 8.
Very nice. 2x plus 8. Very, very good. Exactly, Albert. So Jerry, Emma, does that make sense? Because 8 people came from Kim and go to Amy, right? So now Amy would receive 8 more votes. She originally had 2x votes, and now she has 8 votes more. So she's gonna have 2x plus 8, this many votes now. Does that make sense? It shouldn't be too hard to understand this, right? Literally 8 people from 3x go to 2x. So 3x minus 8, that's the number of votes for Kim now, and 2x plus 8 is the number of votes for Amy now. Okay, so Jerry, any question, Jerry? Make sense? Okay, Emma, that makes sense? Good. And what's the new ratio? 1 to 2, remember? Kim received 1, Amy received 2. So the ratio now is 1 to 2. So just maybe to make it clearer, Kim to Amy. You see, this is the equation we can make. And to solve this equation again, fraction equals fraction, we do cross multiplication, right? That's from chapter 5. That's the fundamental. Okay, so yeah, so I'm just gonna proceed and solve it. So 2 times 3x minus 8 equals to 1 times, so you don't have to write down 1 times, it's just gonna be 2x plus 8. So 6x minus 16 equals 2x plus 8. And move things around, 4x equals to 24. So x equals to 6. Okay? But notice that this is not a final answer. So you have to go back to see what the question is asking for, okay? The question is asking for how many people voted. So x here, s being 6, you have to go back to what you're supposed to understand what it means. So x equals 6, you have to go back here and figure out that, which that means 3 times 6, so 18 people, right here, 18 people originally voted for Kim, right? And 2 times 6 is 12. So 12 people voted for Amy at the beginning. Okay, so 18 to 12, 3 to 2. That makes sense, right? And now let's check if the answer is correct, if our answer is correct. So there were 18 people voted for Kim, and if 8 of them voted for Amy instead, then that means you're going to do minus 8, and Amy is going to plus 8. You will see that now we only have 10 people voting for Kim, but we have 20 people voting for Amy, which becomes 10 to 20, which is 1 to 2. Right? 10 to 20, 1 to 2. And that all makes sense, right? This means that our answer is correct. We check our answer, it is correct. And to finally answer the question, how many people voted? Well, we know that 18 for Kim, 12 for Amy. So we're going to add them up, right? So 18 plus 12 is going to be 30. And another way to know that that is going to be 30 is that, well, we know there were 3x for Kim, right? We suppose there were 3x for Kim, 2x for Amy. So the total will be 5x, right? 3x plus 2x, 5x. So 3x plus 2x is 5x. So the total number of people, the total number of votes is 5x, okay? And then x is 6, remember? So 5 times 6, that's going to be 30. So the total number of people here, or the total number of votes here, would be 30. And yeah, that would be it. Does that make sense, Emma, Jerry? For this kind of question, you always suppose 3x, 2x first whenever you see a ratio. And based on the question, usually it's going to be some x minus a number or plus a number over some other x plus or minus a number. Okay, because this kind of question will always have this kind of condition. Okay, 3 people are gone or whatever, you just do some addition, subtraction, okay, and then equals to another ratio, and you cross multiply and solve the equation. Okay, Albert, does that make sense to you? Okay, everything good? Then let's do another example. Okay. The other day I had just gone through another example. I want to show you how this is done. Let's see. Where's the other? Yeah. No. Okay. Can't find it. Just 1 second. Remember, there's another. Well, there were many other questions. This kind of question is very popular in math competitions and also school math. So I want to find out. Let's see here. Give you some more. Let's see. Okay, this. Okay, we can do this. This is actually easier than that. But it doesn't hurt to have a look. The same method, okay? Okay. So very quickly, you don't even have to read this. Basically, some guy is planting pea plants, okay? There were 4 types of pea plants. There were tall green, tall yellow, short green, and short yellow, okay? 4 types of pea plants. And the ratio of them is 8:5 to 2:1, okay? And in total, there were 1,080 green plants, okay, pea plants. So, sorry, there were 1,080 green plants. Okay, so that means short green and tall green, they add up to be 1,080. And it's asking for the number of total plants in his yard. Okay, I'm gonna do this one for you again, just as an example, and maybe I'm gonna pull out another question and for you guys to try. Okay. So again, there were 4 types of pea plants, and the ratio has been told, right? Whenever you see this and you need to figure out some like exact numbers, exact quantities, you suppose, just like we supposed before. If you have 3 to 2, we do 3x to 2x, okay? So what about the ratio here? This is a 4-way ratio, 8 to 5 to 2 to 1. How can we suppose the number of each type of the pea plants? How do we suppose the number in terms of x? It's 8 to 5 to 2 to 1, right? So we can just suppose tall green to be 8x, tall yellow to be 5x, short green to be 2x, and then short yellow to just be 1x, which is just x. Does that make sense? Right? Exactly the same kind of method, right? Okay, so Jerry Emma, does that make sense? When you see 8 to 5 to 2 to 1, you do this. Because in other words, how do you even know the quantity of like the exact number or the exact quantities of these four kinds of pea plants? Well, they could be just 8 to 5 to 2 to 1, or you can time it by 2, right? Maybe you have 16 of tall green, you have 10 of tall yellow, you have 4 of tall green, and you have short green, and you have 2 short yellow, right? Or maybe you can time by 100. Maybe you have 800 tall green, you have 500 tall yellow, you have 200 short green, you have 100 short yellow. But you don't know by what number you should time this ratio, right? You could time it by 50, you could time it by 55, okay? So you don't know, so that's why we just suppose the number we're gonna time by is x. So that means you have 8x tall green, 5x tall yellow, 2x short green, x short yellow. And again, if you just cancel out the x's, you just get you will just end up with this ratio, 8 to 5 to 2 to 1. Does that make sense? That's how we suppose. Okay, always remember in this kind of question, if you need to know the exact quantity, you suppose. And based on the question, you try to come up with an equation. Okay. The question says there were 1,080 green plants. So we have tall green 8x, short green 2x, and that's going to be the total number of green plants, right? So we add them up. So tall green plus short green plants, right? Green plants are only two types, tall or short. So tall green plus short green, tall green would be 8x, short green would be 2x. Then that means in total, you have 10x green plants, right? And the question tells you that 10x is 1,080. You have 1,080 green plants. That's 10x. And then divided by 10, obviously, x is 108. See? So this tells you should multiply the original ratio by 108 to figure out the exact number of each type of plants. Okay, so if you want, you can time this 108 by 8. I don't know what that is, but yeah, just 8 times 108. That's the number of tall green. 5 times 108. That's the number of tall yellow. And 2 times 108. 2 times 108. That's the number of short green, right? And 108 is just number of short yellow. Does that make sense, Albert, Jerry, Emma? So it's very easy, right? If you just suppose and based on the question, you come up with an equation, solve for it, you will know everything. And in the end, it's asking for how many total plants are there in his yard. Then, well, you can just add these numbers up, or to make it simpler, the total number of plants is just gonna be 8x, 5x, 2x, x, they adding up, right? It's gonna be the sum of them. So you can just do 8x plus 5x plus 2x plus x. And that and how many x is that? It's 16x. Yeah. So 16x, x is 108. So the answer would just be 16 times 108, whatever that is. Okay, does that make sense? It's usually the question is asking for the total. So you have to add up all the x's to figure out the total x and just time it because you know what x is. So it's very similar to this question, this 763. It's also asking for the total number of people. So you can do 3x plus 2x, you get 5x, and your x is 6. So you just do 5 times 6, you get 30. Okay, make sense? Yeah. We probably won't have time for other questions, but I really believe that this type of question is very important. So we're gonna spend maybe some more time doing it again. So let me find another question here. Let me see if there's any other question. Ratio. Any ratio here? This is ratio. Yeah. Okay, this could be one. Okay, here we have some fictional fictional, I don't know, Galaxy Corps members. Okay, something called a Red Lamp Brigade and Green Lantern Corps. So these two words might be too hard. So Emma, brigade 就是这个军队啊，那个旅的意思，听说过吧？比如说那个就是最小的叫班嘛，班呀，然后排呀，然后一个连嘛，然后一个团，然后一个旅叫一个 brigade。这个 corps 呢，就是个军团的意思。 所以这里呢，其实说半天就是说什么一个红灯军大战蓝灯军，好吧？大战绿灯军啊，红灯大战绿灯，无所谓啊，它只是一个就是一个虚构的东西，好吧？Just try to understand the essence of the question, okay? If you have any words you don't understand, you can always check it up, but just focus on the information, okay? So what it's talking about is that you basically have 3,600 600 sectors of the galaxy to guard, something like that, right? They have a war here. What it is says is that each sector you only have one core member or one brigadier. You could just say a red team and a green team. Okay, you have a red team, you have a green team, you have 3,600 locations to occupy. Okay, and each location can only have one team member. Okay, what is saying here is that you have, so in the first 2,400 locations, the ratio is 3-1 between green and red. So core is green. This is actually green. Core is green. Brigadier, that's red. And in the end, it says if brigadier and core members are the same, if they are the same, what is the ratio of core to brigadier in the other sectors? Okay, so first we can figure out among the first 2,400 sectors, how many green and red members are there, right? In the past, we learned that if you have, so here basically the information is that you have 2,400 people, okay, let's just say people, members, and the ratio of those members, green to red, is 3-1. So in the past, we learned that we do 3 plus 1, right? Remember, we do 3 plus 1, there were 4 parts, and we do 2,400 divided by 4, right? But today, we learn how to suppose the x's. I want to use the x's and explain this, and to further explain why do we do 3 plus 1, okay? So if you need to suppose the exact numbers, here, of course, we do 3x, 2x, right? So we suppose that there were 3x green members and x red members in the first 2,400 sectors or locations or people. So that means the total number of people here, the total, that will be just 3x plus x, which is 4x, okay? So the total is 4x, and we actually know that the total is 2,400, it's given, right? So we just say 4x equals to 2,400, and that's why x is just 2,400 divided by 4, 600. Now, isn't this the same method that we learned before, 3 plus 1? Okay, so this is another way to understand this. Before we explain that, you could say you could see it as 3 parts to 1 part. You add them up, so 4 parts as a group. Remember, as a group, and you divide 2,400 by 4, you get 600 groups. That's one thing to understand, right? Another way to understand this is to suppose the x's. 3x plus x, that's 4x, and divided by 4. So that's why you do 2,400 divided by 3 plus 1 if you use algebra. Okay, makes sense? So 2 ways are both fine. Just I want to explain how do you use algebra here. Okay, before we said that so green, 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 red, right? 3-1. You could see this 3-1 thing as a group, right? This is a group. Each group is in each group you have 3 green and 1 red. So that way you can always make sure the ratio is 3-1, and you just need to figure out how many groups you have, right? In total, you have 2,400. So divided by 4, you get 600 groups, and you time 3 back. You time by 3, time by 1 to figure out their exact numbers. But if we use x, that's the same thing. Okay. And for this question, it's actually pretty easy because if it says if there are an equal number of green and red, what is the ratio in the other sectors? The total number is 3,600. So if there were an equal number, that means both green and red have 1,800, right? Both of them have 1,800. In the first 2,400, their ratio is 3:1, but we figure out X is 600, there were 600 groups. So they, in terms of the exact numbers, there were 1,800 green and 600 red. And we know that in total, you only have 1,800 green, right? So that means 1,800 green already here. That means in the remaining 1,200 sectors, all of them are red, okay? So 1,800 green, 600 red. That means that in the remaining part, you have all reds. Okay, so in the remaining part, it's asking for the ratio, and the ratio green to red, you could just say it's 0 to 1,200. Okay, the second part is not that important. It doesn't involve X, okay? Just this part. And this is a very easy X. Yeah. But anyway, okay, I hope you guys get the idea. Okay, so you have a ratio, and if you need to find the exact quantity, you suppose X's based on the ratio, very straightforward. And based on the question, you try to come up with an equation, and that's it. The hardest kind of question would be actually be 763, because in the end, you have to do minus A plus A based on the question. You have to equal to another ratio. This is like literally the hardest kind of question you can get. Okay, hope that makes sense. And yeah, okay, and we still have 3 more, 7, 64, 65, and 66. Maybe next time. Okay, so now we go to chapter 8. Try to do some more percentage. Here we have some more questions for Emma. So Emma, this question B, you got it wrong. Let's have a look. Okay, so it's asking 2 is negative 50% of what number? Okay, so whenever you see what number, you have a number you don't know, you suppose X, right? Okay, and Emma, I was trying to tell you, in WeChat that you have to correct the past questions, right? Because and also for Jerry too. Okay, you two have to correct the past questions. Albert did it every time. Okay, because every time when I assign homework, it's previewing, right? Ask you guys to preview. So when you preview, it's normal, it's understandable to make a lot of mistakes. It's okay, right? So Jerry, Emma, you guys had some wrong questions. That's fine because it's previewing, okay? But after we talked about them, you want to correct them, and you want to really just to make sure like that you understand, okay? Because I don't know if you understand or not. I'm not inside your mind, okay? I cannot read your mind. I'm not sure if you understand or not. You but you know that if you understand or not, right? If you understand it or not, you totally should be aware of it, okay? Just make sure, be responsible for yourself, okay? Be responsible for your own study. Make sure you understand, and do the wrong questions again. Make sure you understand. If you don't understand, let me know, right? I can help you, okay? So correct your homework. For this question, we suppose the number to be X, and then just make an equation, okay? Whatever percent of a number, we time them, right? So we do negative 50% times by X equals 2. To solve for this, change the percentage into over 100, right? So negative 50 over 100, X equals 2, or 50% is 1/2. I think everyone knows, right? So negative 1/2, or here you can divide by 50, it's just 1/2. X equals 2. So X equals, basically time by -2, right? So 2 times -2, you get -4. And that's it, okay? And in retrospect, this should make sense, Emma, because you should know that 50% is 1/2, right? 50% is 1/2. So forget about the sign for now. You can deal with the sign later. So 2 is 1/2 of what number? Well, of course, it's going to be 4, right? 2 is 1/2 of 4. 2 is half of 4. And if you have a negative, then you should get a negative here. Just -4. Okay? Good. Next, this question also for Emma. 8.7. It says if 20% of x is y, then 35% of x is what percent of y? Okay, so the first if part, we make an equation. We know that 20% of x is y. This is what we know. And the question is, what about 35% of x? 30% of x equals to what percent of y? That's what the question is asking, right? So we know that 20% of x is y. So for 35%, you could see that 35% as 20% plus the 15% of x. Okay, so basically you just need to figure out what about 15% of x. Okay, so 20% of x equals y. What about 15% of x equals to how many y, right? To do this, you can always first figure out the 1%. So think about this. This is 20%. If you just divide it by 20, you get 1% of x, right? So 1% of x, you divide it by 20, so divide it by 20 here. You also need to divide it by 20 here. So 1% of x is actually 1 out of 20 y. Or if you want 1 out of 20 to change it into a percentage, you want to make the denominator into 100. That's 5 out of 100 y, which is 5% y, right? Okay, Emma, does that make sense? Right, 20% of x is y. Then 1%, you divide by 20, that's just 1 y over 20, or you could say 5% y, because 1 out of 20 is 5%. Okay, so 1% of x is 5% of y, then actually we don't even need this. Then that means 35%, you just times by 35, right? 1% is 5% y. You can write down here again. 1% of x is 5% of y. So to understand, to know 35%, just times by 35. So you times by 35 here, you times by 35 here. Okay, so 35 times 5, that's 5 to 175. So yeah, 35% x will be 175% of y. Okay, and this is similar to ratio problems. In ratio problems, you also do division and to figure out like the unit ratio sort of thing. Okay, so Emma, that makes sense? This kind of question, you always, so whatever percent you have, you divide by that number. First, figure out a unit, like 1%, 1 to something. Figure out the 1, and you can go from 1 to any number. From 1 to any number, you just times by that number. Okay, so basically first divide by yourself, divide by the number itself, whatever number you have here, divide by the number itself to get 1, and then time by another number to get, well, that number. Okay. All right. Good. So 8.1 we now finished. So Jerry, Emma, you guys have some some wrong questions here. I want you guys to correct as your homework. You see. So for Emma, you have these questions, and then Jerry, you see you have these ones. These are Emma's. So about 8 to 10 questions. Okay. So please correct them, Jerry and Emma. Okay. And for Albert, you also have 2 questions here. Yeah, and please also correct them. Okay. And so yeah, just 8.2, 8.3. Try to correct all your questions. Try to do your best. Because after 8.4, chapter 8 is finished, okay? So spend more time doing chapter 8, and next time we can basically finish chapter 7, and then chapter 8 maybe half of it.